All right, let's do this, guys. I think I'm finally ready. Oh, welcome everybody back to Better Biomed. I had an epiphany in the middle of the night of why my system wasn't working. I was feeling a little bit frustrated, and that's why I stopped my stream maybe a little bit early yesterday. But that's okay. I figured it out. I figured out my stepper motor driver, and excuse me while I finish getting some stuff set up for today. So I had an epiphany last night of the ground problem. So we seen the pulses. We've seen the pulses, but they weren't a natural looking pulse. So the pulses that we've seen for pulse, direction, and enable on my stepper driver, they were distorted. And usually when it's distorted, that means that, I mean, you're getting a positive pulse, it's just the difference of potential isn't there. And that was exactly what we were experiencing on my stepper motor pulse generator, all right? Hasib, Mr. Hasib. Guys, one of my mentors, Mr. Hasib, is watching. No pressure whatsoever, right? So, Mr. Hasib, sir, we are building a DC trainer so that I can train students, get them interested in electronics, and to show people how to troubleshoot things like power supplies in the field. So, here I have my AC in through line and neutral fuses, an E-stop only on the hot side. I think on this, yeah, this particular one is only on the hot side. And I will be tripping it periodically just to throw students off, because that's exactly what happens in the field when they step in to actually work on electronics. Is if it's got an E-stop, I always tell them, trip it and then reset it. Now press on with your diagnostics. Okay, so from the E-stop, it comes down here. I have ground, neutral, and line or 120 volt, and all my 120 volts are running through fuses. I can induce problems there too, because with these industrial electronics, you can actually meter across the fuses without removing the fuses, and I can tell immediately if they're good or bad, which is awesome. And from here, my line are run to each and every one of my power supplies. So I have a defective external power supply. I have an open frame, I have a closed frame, and I have a generic power supply out of a medical device. The open frame unit down here, it's also defective. So it pops fuses quite regularly, and that is because right here I've got a shorted bridge rectifier, which, I mean, luckily it's open frame. You can actually meter it and you can see that it's shorted in circuit. So this guy down here, it's actually designed, the jack does not go to anything. It's a regular barrel jack, just like you see on any electronics. Doesn't actually go to anything because it's defective. I want people to get used to metering at the output side. But then if they say, hey, wait a minute, I've got no output, it must be defective, I want to see them also pull off the IEC on the other side and make sure that there's no incoming power. Because I have seen many a defective power cord, you know, it just happens. So I have active cooling for both my power supplies, even though obviously they're not cooling anything, because I want people to get used to seeing and using your eyes and ears to figure out a quick solution to the problem. Because if this guy here has got a active cooling that's spinning and this one doesn't, because usually your active cooling is on as soon as your power supply is on. So if one of them's spinning, one of them's not, you should immediately track to the one that's not as a possible problem. So between all the things that I have just on the AC to DC side, I can induce a whole bunch of problems. Then down here, obviously these are 4mm banana jacks going to each of my power supplies. These two here are the only two that I'll obviously be using. Down here, I have a battery with a float charger mounted on the back, and it goes to a couple 4mm jacks as well. Now, the reason that I have the battery down there is because, especially with medical electronics, we have to check the charging circuit. Well, you know, the charging circuit can actually change its condition based on the battery. So if the battery is internally shorted or it's defective, then it will actually pull down your charging circuit and it'll make it appear as though your charging circuit is defective. So I want people to get used to disconnecting the battery, measuring across the battery, and then reconnecting it, and then measuring the charge voltage. It's absolutely essential. There's two different measurements that have to be done when you're involving batteries. And of course I stuck with a lead acid battery because lithium, people would just catch it on fire. I already know. So anyway, the next step of this project, on this side of the board, I'm setting up a series of motors, all right? So on Amazon, I was able to get a whole bunch of different controllers for different styles of motors. One for a 2-pole motor, and I think the example of a 2-pole motor I'm gonna use is this 24 volt, and I know it looks funky in here because I have it green screened, but this is a air pump. It's an air pump out of a medical device, 24 volt. Now, if they hook it up to the 15 volt power supply, it's possible that they will have some problems, but I have a PWM controller for that one. So how cool is that? So I'm going to show them, and with an oscilloscope, we can actually watch the PWM do what it's doing live while the motor's running. So you can actually see with an oscilloscope, as you adjust the PWM up to increase your speed, you should watch that pulse width also change. So that's going to teach people about 2-pole motors. Now, let's see, I have 3-phase motors, to which I have a blower right here. This guy comes out of another medical device. It is a tiny 3-phase motor. However, it works beautifully with this $12 3-phase motor controller that I got off Amazon. It was like 12 bucks, very inexpensive. I love that. And yesterday I explained how your semiconductors are running in pairs to create your sine wave for each of your phases. So this guy is going to be a perfect little example. I've got yet to come up with a mounting solution for it, but it's going to be over here with a 3-phase motor so that people can see the different types of motors. But that's only 2 types of motors. There is another type of motor that we use all the time here in medical equipment, and that would be your average everyday stepper motor. So here is where I had a problem, and that is because the circuitry here, actually, why am I doing that? I have all this set up to do what I need to do. There we go. All right, guys. All right, let's pull my PWM controller. I don't have that one wired yet. So last time I actually wired this guy up, and there was one thing that was confusing me. So I have on the enable, the direction, and the pulse, I have them wired in parallel for the negative, okay? And then that negative runs all the way over here. This is a pulse generator, okay? So the pulse generator tells this guy to do a power pulse to your stepper motor, and you know, based on the amount of pulses and the direction, the polarity of the direction pin, that will determine whether this guy goes clockwise or counterclockwise. So unlike a normal stepper controller, this guy here will send continuous pulses, and a real good stepper controller actually sends out a calculated quantity of pulses. So I could move this flag 90 degrees, I could move it 2 degrees, actually 1.8 degrees without micro stepping. That's almost all stepper motors can move 1.8 degrees without micro stepping. Micro stepping is when you are kind of crossing the boundaries between your pulses. It decreases your torque and whatnot, but it does allow a higher resolution on motors. But imagine 1.8 degrees all the way around, you got 360 degrees. So that's quite a few pulses to get it to go all the way around. So this little motor right here, I finally figured it out. My negative, here's the epiphany. I had a little jumper down here that adjusts my ground point over here. It's written in Chinese. it was not cool for me to try and figure this guy out. However, last night I thought, you know something? If all these guys here are my positive pulses, even though it's in Chinese and the translation is horrible, I bet you the terminal closest to them is probably the common ground. Even though it doesn't translate that way in Chinese when I use an active translator on my phone. And so I moved it over from the ground terminal over to what I believe was the common ground, and we got magic. We got magic, everybody. Look at this. So the cool thing is, if stepper motors are on, they're locked up. That's their holding torque. If they're being told to pulse, there's a lot less torque on the motor. However, by changing the pulse between each of the coils, you're actually getting it to move. And by changing what order the coils are pulsed, we can change the direction. So that is why stepper motors, you can't just hook them up straight up to a regular power supply, is because it's just a coil, right? And just a coil, there's no commutation in there. Commutation is when the phase shifts to your next coil and pulls the rotor. So since there's no commutation, it just sits there. So when I power this guy up, if I don't tell it to do anything, which I can spin it really, really fast. Oh, and then watch this. I can go super fast. I don't know if you can hear it. I can go super fast with it, and then I go too fast. And when I go too fast, it phase locks. You see that? In other words, it's sequencing the pulses too fast for the rotor to keep up. And likewise, if I go really, really fast, oh, come on, slow down. If I go really, really fast, and then I shut it off, and then I go to start it, see how it doesn't move? That's because the motor needs ramp up time in order for those phases to lock up and actually sequence the rotor, okay? So it's a crazy thing. So what you have to do, normally in circuitry, there is a ramp up time period that you calculate. This is just a pulse generator. It doesn't care, okay? So you have to physically turn it down, and then you can activate it, and now it's spinning. So this thing is also going to be on my board over here to the side, and I just have to come up with a real good way of, you know, orienting it so that it looks reasonable. And I purposely did all the wires with very specific colors so that people can trace what it takes to spin a stepper motor, you know? So for industrial electronics, you need an enable signal that tells it to turn on. You need a direction signal, which tells it clockwise, counterclockwise. And you need a pulse, because it needs to know how far it's gonna move. So that's my stepper motor. And this guy, I have it all figured out. I'm running it currently off 12 volts, and it's pulling 0.25 of an amp. Let's see how many amps I can get it to pull. Wow, I was not expecting that. I should have known better. Okay, so when the motor is going slower, it's pulling way more current. I'm pulling 0.26 of an amp right now when it's pulsing really slow, and when I pulse really fast, I'm pulling 0.18 of an amp. So the current actually goes down because the transition between phases, instead of locking up one phase, the transition actually uses less current. Kind of cool stuff. But that's all stuff that I wish to show on the board to show people like how much current these motors and everything pull. So let me go ahead and disable my DC power supply. Boop. And let's go ahead and get it set up so that I can do the pulse width modulation controller. This guy right here. All right, let's kill the power. This last thing I need is some Archie Spark. Okay. All right, there we go. So kind of cool. A lot of people don't get to see the physics behind the different types of motors. And the real goal of this is to make it so that an average Joe can take a rather mediocre oscilloscope like this, set it up, and actually get a pulse signal and see exactly what's going on. And I can change things, like I can pull out, you know, one of the cables, let's say one of the grounds on the enable. I can disable that line, and now it's no longer enabled. So they're like, wait a minute, I got pulses, why isn't it moving? You don't have the enable signal. You gotta have them all. But you can see that with an oscilloscope. Okay, let's go ahead and move this guy off to the side very delicately. Oh. Now I do have my second camera over here. I will be setting that up when I'm positioning the elements on the board. So one of the next things I gotta do is I'm gonna be drilling, and I'm gonna be placing 4mm banana plugs here, so that I can enable and disable certain motors. And because they're going to be barrel jacks, you can run them off 24 volts, you can run them off of 15 volts, and maybe I'll get a little 12 volt or a little 9 volt over here, because I do want people to see that, you know, as you decrease voltage, you're probably going to be increasing your amperage, especially when you're talking about motors. Motors get pretty fussy when they're run out of their normal spec. So here's my 3-phase kit. Let's go and put him over here. All right, so my pulse width modulation kit, and tell you what, that is, what is the rating on this guy? Just says power minus and power plus. I don't know, guys. Power minus and power plus. I guess we can try to run 24 volts through it. Why not? Here, tell you what. Let's see if the Chinese on the board, I use Google Lens for all this kind of stuff. Let's see if the Chinese on the board tells me my input voltage limits. And no, it just says power in. Okay, well, worst case scenario, it only cost me $9. If we blow it up, we blow it up. Who cares? It'll make for a more interesting video, that's for sure. Okay, let's clean this guy out. Let's switch to the overhead. All right, and gosh, I wish I could zoom that guy a little bit better. Oh, I can't, physically. There we go. Now you guys can see kind of what I'm working on. All right, so this here is pulse width modulation. You've got positive and negative in, you have positive and negative out, and all it's going to do is chop up the voltage that you supply it to drive a motor. And in this case, I think I am going to try that little air pump. And I don't know what I did with it, because lately I've been flat surfacing a lot of things. I do have a 12 volt motor right here, just a single phase. I have a little 6 volt motor right here. I have, man, I just have a lot of motors, guys. And let's see, where's the other one? Okay, well anyway, let's go ahead and let's wire it up. So my power input, we need a positive and negative, just like these. So I need to clip this guy down because it is a little bit too much. And yesterday, one of the things I found out when I was running with these fair rules is that after I clip them to length, to recrimp them, that puts them back in their square. And when they're back in their square, they fit in the hole so much better. The reason I'm clipping them is because I don't want them sticking out of the connector very far. You can tell that it's kind of a small screw down connector. There we go. Excellent. Okay, so power in. Got negative on top, positive on the bottom, no problem. And let's see. Yeah. Oh, not so bad. All right. Excellent. Let's do this. Keep the orientation of these guys the same. There it is. All right. And I'm going to strip these guys back. Now, I've never tried this one, so for all I know, it could fail. What, that's the odds. Oh, that's right. I had it right here. So I've got a 24 volt, 6 volt, and a 12 volt motor. People should be able to hook up any one of these motors and see them doing something, and it's gonna run crazy. They're gonna either run hot, or like the air pump, if they don't supply enough voltage, it will stall. And if it stalls, the current's gonna go up. So all this is gonna be experienced by the student. Let's see, I need 2 more wires. Black and red. So this is going to be my output to the motors. There we go. Excellent. Let's strip them. Let's get them set up. So every single one of these joints are going to be done with fair rules. That way there I can disconnect them during class and induce new problems for the students. Excellent. Okay, motor plus. Maybe that guy. Mr. Hasib, I hope you are having a fantastic day there, sir. I went for a really long bike ride with my kids this morning in 90-degree heat, and my wife was very upset at me for that, but the kids loved it. So now it's time to do some electronics. Well, come on, man. What's going on? Let's clip these guys down. They're a little bit too long. Notice I'm clipping everything over here in a tray so I don't get a bunch of metal in my arms. And again, recrimp. All right. There it is. Oh, that did not want to go in too well. All right. Excellent. It's not the prettiest thing in the world, but it will certainly work. Especially to prove this concept. So this is a 3-position switch. So interesting. I'm curious if that's reversing the polarity and in fact reversing the motor. We'll see. We'll see together, right? Okay, let's put these two here. These are my input power. So here's my negative. And hold on, guys. Right here's my positive. And let's see, this guy here, we'll hook up the 12 volt motor just to be safe. It's the happy medium of the group. So today, my goal is proof of concept to make sure that each and every one of these components works before I fix it to the board. And as soon as it's fixed to the board, then I can build out the rest of the board. I'm just going to set the ferrule on there just to create the connection. There we go. I'll tuck my positive over here. There we go. Okay, so we should be good. I think I'm running at 12 volts over there. This is a 12 volt motor. We should be all set. This is off. This is off. Okay, let's check it out. Tell you what, let me get a flag to put on there as well. There we are. All right. All right. That's my flag that should flap around depending on the direction. Here we go. Let's power on. All right. So on this 3-position switch, click it on. There we go. Wow, I can actually. Okay. Let's see if it reverses direction. Yep. Okay. Well, that's kind of cool. What a neat little device. Normally I'd have to build that circuit myself. Very responsive too. All right, so here is why I wanted to do open connections. All right, let's go ahead and turn it on. Let's check it out and let's see what we're getting. So you should see a definite pulse change. If everybody can see my oscilloscope here. Okay, here we go. I need this guy. Okay, and put it on auto mode. I know some people despise auto mode. Okay, so let's change the pulse. Look at that. How beautiful. So what we're actually doing is we are changing the pulse duty cycle by making it longer. You can actually see that the pulse is in the negative direction. Let's go ahead and change it. And look at that. Now we have a pulse in the positive direction. Huh? Pretty cool, huh? I can't wait to show people this as it happens. Luckily, I've got a multi-channel oscilloscope because when we do 3-phase, I want to see that phase relation. So, yeah, there we go. Cool. It works. I'm so happy. So that is with this motor. I really kind of want to see this one. This is an air pump. That worked out kind of well using ferrules as wire junctions. Okay, let's take this guy, set him off the side. I dig that motor. And let's see. Let me get a couple more of these guys. Okay, there's that one. I'm gonna stick him right down in there. Yes, guys, I use my environment when I am doing electronics. You name it, I do it. Okay, So this one here, I do believe that there's a protection diode on it. Oh, come on, come on, come on. So it is polarity sensitive, which means it might not like it when I reverse the polarity. There's that one. And let's get the positive hooked up. See, this is why I want to put it all on the board, so it's all nice and organized. It can get messy real quick, guys. Okay. And my oscilloscope probe, let's pull it out. You guys already know what pulse width modulation is, I just showed you. Okay. Next would be to power up this guy. Let's see if the air pump does anything. All right, gotta remember that guy right there. Okay, it's running. It's easy to stall out, you see that? And when I stall it, it goes up to 0.4 of an amp. Also a cool thing to demonstrate for people. Yep, 0.4 of an amp. Okay, let's reverse it. And when I reverse it, notice how nothing happens. So it is a polarity sensitive motor. And we're currently running at 12 volts. So you can hear it. It's still trying. And that's with here. There you go. Okay, so this motor is going to work. I'm using a 15 volt and a 24 volt power supply. Excellent. Here, let's go ahead and shut the power off. So every single one of my motor concepts, they do work. They're working kind of well. So next phase, let's do it. I like it. I have all sorts of these jumper wires sitting, like hanging from the wall right here, because I can quickly and easily make up jigs to test things very quickly, in fact. So this guy is all set. Let's set him on the bench of chaos. All right. So today we're already off to a roll. And let's see. So my bench power supply is over here, and I ran cables all the way down the back wall, and they come out over here because this wall is where I want to do demos and, you know, testing. This right here is more of a desk space, although today I'm using it for, you know, making wires and stuff. But anyway, over there is where I normally want to do this kind of work. And I made extra long wires, like all these wires right here. I made jigs to help me out. And you can see what a bunch of chaos. It's a good thing we're working with low voltage. All right, I'm gonna put them up. Got some extra long wires right here. So what I've got to do is I want to have switched positive only. Positive only. So that means I'm going to use a bunch of the red ports. Let me get this camera set up correctly with the charger, because last time I was filming and it went black and I didn't realize it until later. These 4K cameras suck the juice. Okay. And with this camera, I can also give you guys zooms to show you exactly what I'm doing. And it's a mobile camera, so I can move it around. How cool. And let's see, let's switch it over. Bam. Switch this guy on. And we should have action. There it is. I knew it was gonna work, guys. So with this one here, I can zoom in quite well to show you guys what I'm doing. Okay. So I'm not too worried about the mess. I'm definitely gonna make a mess drilling out some of these ports. So I have these ones installed. I need 6 more installed. You know, and I was going to do this on my own, but I figured why not? Let's just let the camera run. If I mess it up, well, you guys will know that sometimes I do have a little bit of profanity, unfortunately. All right, and I do believe this is the port size. Let's do it. Let's run 1. Whew. Okay. So I'm trying to be kind of careful because if you push too hard, you'll get tear out on the backside, and I got minimal tear out. That's good. Let's see, where's some of those jacks? All right, guys. So I've got a whole bunch of these jacks that I want to install. Go there. Excellent. Perfect. Okay, so these will get installed just like so. And I need my hot glue gun. All right. Tell you what, I think this would be better if I move this camera back so I don't bump the camera. And I just use zoom. There we are. Not so bad. And let me get some more light. Ta-da. Okay, next step. Let's go ahead and get the hot glue gun done. This is how I'm going to affix the ports in the board. If it's done correctly, they will stay for years to come. Okay. There we go. Let that guy heat up. Get all my ports ready. 2, 3, 4, 5, and 6. So you can see on the back side of the port, there is a flat spot for a spade connector or to solder. That is also a point where I can induce other problems, because just because you have this on or off, how do you know you have voltage here? Again, they should be able to measure that, you know. The whole thing is about being capable. And let's see, to put these in smoothly, I think I'm going to use come on. All right, so to put these in smoothly, wow, is that gonna be too tight? Okay, I'm gonna hold on to them with, oh man, nothing's really working today. That's all right. I'm gonna use banana plug to hold it so that I don't burn my fingers. All right. There we go. The other day I injected glue from the backside, and I think that worked maybe a little better. Because I do want the finish to look very professional. There we go. Excellent. Next. Yes. Okay, that worked out really well. Okay. I need a hook to hold this. There we go. Okay, and I need 3 more holes. That's so funny. I don't know why it's squeaking like that. It's a tight fit. Okay. Clean, clean, clean. Nice. That works so much better. I'm putting glue way down the shaft, and then I'm rotating it and pushing it in, and it creates a nice, neat seal without too much splash of glue. Nice. Boy, I wish I would have done that to those ones. All right, who cares? We learn. And let's see. I'm going to have to rotate this board here in a minute. So each one of these is going to be wired up to these. All right. All right, and this guy here is wired up. So I think now I'm going to have to lay it down and then figure out where the motors are going to go. Okay. This is a cool device that I've got this sit in. It's called a jaw horse. There we go. Now here's where I have to be careful, because I don't want it to damage those ports, which I think I already did. Darn it. Okay. So something like this here. And let me get a block of wood for the other side. Yes. Perfect. All right, so I think I damaged one of my ports over here, but it doesn't matter because those ones are for the defective power supply anyway. Nice. Now it's on there nice and steady. All right, guys, let's bring you in so that you all can see what I'm doing a little bit better. All right. Luckily, this is a mobile camera. And down. There we are. All right. Sorry about that, guys. By chance, is this somebody from Russia? Look at that. Ah, well, hello. Okay, so here I've got these set up. Now, what I did want to do is a ground bar or a common so that these guys here can come up to a common, and then, you know, all the motors and everything will be connected. So on this particular design, only positive is going to be switched. And now let's see how we're going to lay this out. How are we going to do this, guys? So my simplest one, the PWM. And the 3-phase. So I need to fit all 3 of these on the same board. And then what I wanted to do is drill through the board and have my wires go through the back. Okay. So 3-phase. I think I want to do it in order of complexity. So we'll do PWM down at the bottom. Okay. And I think the motors, I'll have the motors over here at the far side. So this little bad boy is going to be right about here. So this right here is kind of the goal. Okay. This right here is the input power. These 2 here are the outputs. So what I really would like is a couple standoffs to hold this off the board a little bit. I don't know if I have anything like that. I have many fasteners here, guys. Okay, well, I think I found a couple things that might work. I also have these feet. Where are they? All right, let's see. I've got racks full of stuff down here, guys. And one of the things I'm looking for is these little rubberized feet that you can stick on the bottom of your project. Because I need something to hold the board, hold the little guy off the main board there. Oh, nice. I found some momentary buttons. Those are kind of cool, right? Look at that. You know something? Why not? Why not? Oh, shoot. Okay. Maybe I'll wire them in parallel so you can either do a switch or a momentary. Or one momentary. I'll just do one. Okay. So yeah, I found some miniature momentary switches. Cool stuff. The standoffs I'm not seeing. Shoot. I might have to make some out of rubber hose or something. Which I can do. I mean, if it appears like I'm unorganized, guys, it's because I am. It's because I am constantly busy. Oh, you know something? I don't even necessarily need that. I have this stuff right here. Boop. So this stuff is some of the craziest adhesive ever. It's made by 3M, and it does have an insulative property to it. It's wood, so I don't have to worry too much about insulating. So what I'm going to do, I'm going to cut this guy in two, like so, and then I'll put two of them on the back side, and that will keep my control board down here attached to the wood. It's probably going to work really well too. Oh no, it's a little too long. Okay. You know something? Hold on. They put a fastener on the back side of that. I'll save this for something else. They put a fastener on the back side of it, so that it creates a problem for me because it'll be teetering, and I want it to be anchored. So I'm going to go to Old Faithful on this one. Come on. There we go. All right. So I'm going to actually use glue as my anchor, and then I can use fasteners. So this is going to be my standoff. That's going to be the goal. I'll do it right. Come on. Right like that, right there. It takes a moment for that gun to heat up. Beauty. Now I gotta hold it there for a moment while it cools down. Excellent. So people can still get in there and spin it. No problem. I'll come back and I'll sink fasteners in there. Now this guy here, I'm planning on putting like an L bracket and mounting it to that. So while you guys see it just dingle hopper in here, it will be fastened down eventually. And one of the things I can use this super sticky on is this guy. Hold on, let me clean that base plastic. All right. Clean all the oils off it. And my motors are going to be over here, so my controller is going to be right about here, I think. Yeah, something like that, right there. There. And again, I'll come back through later and sink these down. The hot glue is actually perfect because the uneven back surface, it adheres quite well. Like this guy's already stuck. Look at that. It's on. Okay, so we got this one, we got this one, and I'm going to do the DC ports for each of them so that you can run your DC. And let's see. This motor here, oh shoot, I just touched it. Shoot, did I just put that board on backwards? I'm thinking something like this. Okay. Or maybe down here. And let's see, where's my screwdriver? I gotta get this part right, other words, I'll be in a world of hurt if my leads are too short. Here's a question for you guys. So I've got 3 wires here on this motor. Do you think my motor should go to 4mm jacks like these guys over here? Do you think I should have like 3 jacks next to my motor? I'm almost thinking that's what I should do. And if I did that, then people would run their own jumpers, you know, to basically build the circuit. That's kind of what I'm thinking. It's going to use a lot more ports, but I think, ouch, darn it, it got me. I think it would be a little bit cooler. Let's go ahead and put a couple pieces on this turbine. And excellent, perfect, it's gonna fit. Come on, come on, come on. There we go. All right. I think that's what I'm gonna do. I'm gonna have it kind of blowing off to the side. Yeah. Yeah, I'm pretty sure that's what I'm gonna do. Okay, let me see. So I gotta be careful because I got that plastic block under there. I don't know. I don't know, guys. I'm really kind of thinking about this, like whether or not somebody really needs to wire it up. I don't think they do. Let's just connect it. So 3-phase motor. This, in the video I did yesterday, it actually showed that it was not polarity sensitive, which was weird. So this turbine right here, it runs in the same direction regardless of the polarity of these 3-phase wires. Don't really understand how that happened. Don't really want to tear it apart to find out. Okay. And the 2 wires that are remnants, these guys right here, those are for like a speed sensor, which maybe I'll figure those out later. Yeah, something like that. Mind you, this is my first version of this board. There probably will be future versions as I take it around and show people. Come on. This 3M tape, it's called VHB, and it is super adhesive. There we go. Perfect. Perfect, right there. All right. It is going nowhere at the moment. I might change that location later, all right? Okay, so these guys are also going to be mounted on an L-shaped bracket. So I'll have one over here for this guy. Then I'll have these 2 right here for my on-off and my pulse frequency. So now I've got the hardest one. I've got the, what did I do with it? Where's my stepper motor? Oh, right here. Okay. This one's going to be the most complex. So I've got the controller, got the motor. And I do kind of want it set up like this. So for that, I'm gonna have to drill through this guy in order to create holes to sink down into the board. Or I could just use the existing points like that, but I think I want to do it that way. Okay, I'll tell you what, for that one, just the same. Let's see. So this little motor right here is going to get stuck up there. If I do this right, then I won't even need this long of a board. That would be kind of cool. I would like to trim off like this much. Let's see, this guy. Okay. These wires are not cooperating, guys. I think something like that is how I want it. So one of the first things I noticed is that my my heatsink on this guy is moving around quite a bit, so I'm shooting some hot glue around it to stabilize it. Let's let that cool down. I need that guy to be stable so it doesn't fatigue the legs on that switch. All right. I think it's just a MOSFET on that guy. Okay. So I think that's how I want it right there. Da-da-da-da. All right. It's such a pain to peel this label off this VHB tape. There we go. Excellent. Those go down. I'm trying to figure out the correct orientation for this guy right here. That looks very messy. If I bundled those wires together, I kind of like it like that. Right, let's do it. There. Okay, there we go, it's set. I also wanted to include this guy. Looks like it's a little bit larger diameter. Let's put a momentary switch right here. Okay, a little bit larger diameter. All right. So yeah, let's move the camera so you guys can get a better view and without me hitting the camera all the time. Okay, so I need this guy to go in here, so I need a little bit larger drill bit. It appears that I'm missing one of my calipers. Here, I'll just use this set. All right, so to find the diameter for the drilled hole, just going to use the calipers. There she is. Now I'll find a drill bit that matches that, and Bob's your uncle. Okay. Let's see. Close, very close. There we go. Perfect. All right, and it's gonna be a tight fit. Yes, perfect. Okay, let's use the same technique on this one. All right, and I have a momentary switch. It's subtle because it's tiny, but it works. Okay, let's go ahead and change this guy back. Okay, so this guy right here, I'm going to have to drill. And it's gonna have to be a tiny, tiny little drill bit. Let's see. It's too big. Beautiful. Okay. I do believe that that is a dull drill bit. Let's change it out. I think it's 3/16. This is a little better. Much better. There we go. Okay. those two. Let's do one up in the top. I gotta do this from the other side, guys. All right, let's see. I'm gonna use a couple of my screwdrivers here for alignment pins. There we go. All right, that's looking pretty good. Excellent. Okay. Let's put him back. And I want to fasten this guy right there. Nice. And probably the best way to fasten that guy down would be some thin zip ties from the back. Okay. Hold on, guys. I'm looking to see if I got the correct length zip tie that I'd really like. Okay. So the goal is to have it come up through a hole, down through a hole, and leave a nice clean finish on the front. And the problem is there's not really enough real estate there for a head, like the head of a fastener. So that's why I'm choosing the zip tie method, is because it's going to work, and it's going to work absolutely fine. Come on. I wish I had a little more light down here though, so I can see what I'm doing. Okay. Beautiful. And just like that, it's held down. Yeah, nice professional finish. It looks really good, and it's stable. Okay. Okay. Excellent. There we go. How about that? So my next step is to drill right here. I need an allotment so I can go through with my wires. Ay-ya. Let's clean these up. Adhesive, all this is done. I think I'm still gonna need this guy. Okay. So here's going to be part of the trick. I need one hole right here. Clear? Yep. Beauty. All right. Uh-oh. Uh-oh. Gosh darn it. Okay, so this guy here has clearly lifted up. So in order to reset glue that has shifted, we need a heat gun. So let me get my heat gun out. I guess that is one of the cool things about it, is you can reset it, but it's just a pain in the butt. Let's put this guy right here. I should have been watching it as it was curing. Getting closer, getting closer. There it is, much better, much better. All right. Now I just got to hold it down here until it cures back to its new position. Kind of annoying, but you know, stuff happens. That's the cool thing about hot glue, is you can reset it if you have to. It's okay. Ooh. I'm gonna stick some more glue underneath it. There we go. Now this time I'm gonna hold it. Not leave it up to chance. So Tell you what, that hot air gun definitely heats up this whole entire board. All right, so my DC trainer is almost done. Next, I'll have to make my jumper wires, and from there I will have to create all the through holes. And then it should be pretty much done. Pretty much. Should just clip these two wires right off. They're unnecessary. Come here. There we go. Too easy. Here, that should keep it down. Okay. Let's see, I've got this, I've got that. This guy here, I need my DC in. And then I've got to do the ones down here for this guy. So I'm gonna have 2 ports over here. I think maybe 2 ports down here. I gotta think this one through. Well, I'll tell you guys what. I'm gonna let that cure, and I'm gonna figure out the layout of some of these other components, and then I will do a final video when this guy's all done, because I still have to make the jumper wires and stuff, and that is going to take a long time, unfortunately. Probably hours. So guys, sorry, not going to finish it this time. However, I'm a wee bit closer, and I figured out a lot of things, and we got some good demos of different motor technologies. Now that every single component's tested and functions, I think my very next video will be the final video when I actually have it all set up, and I'll run you guys through it exactly how it's going to be used as a trainer. Probably the best way to do this. So anyway guys, thank you all for tuning in for this probably lengthy video. I have no idea how long I've been live, probably like an hour and a half or so. But guys, I just want to say I'm getting really close to something really good here, and I can't wait to show you guys the finished product between the AC trainer and the DC trainer side by side. It's going to be really good. So anyway guys, thanks for watching, and I hope you guys all have a fantastic weekend. It's going to be a really good week. I have faith